Off we go. So today we're going to talk about a wonderful topic. It's called the big three. Three very important things we have to care about in this class with our C++ stuff, with our classes that we make. Hint, hint, the way that I taught you how to make vectors is incomplete. It works, like you push back does things correctly, like it's fine. But at the same time, it's not fine. We'll get to that, okay? So yeah, I want to teach you this thing called the big three. And this is warning signs, difficult concept. Okay, so traditionally this is a hard thing to wrap your mind around in this class for most students, so definitely pay a little bit extra attention than you normally do to these slides. All right, but I promise you will get it and I will help. So yeah, let's start with this idea. Very simple class, and we're going to like spice it up as we go on, and we'll see the potential issues that I want to show you and how to fix them. All right, with these things called the big three. All right, so let's make a class called box. And its job is to be a box. It holds one thing, it'll hold an int. All right, so every box has one member variable called val, let's say, and it has an int inside of it. And I can mess with that by like the constructor maybe initializes the value inside the box to be 0, and then get val and set val like are our getters and setters that let us mess with that private thing in a public way. Okay, so let's do that. And do shout out the second you have a question, but box class time. So I'm going to put this in box_simple.cpp. That'll be the name of this file when you look up things later, because we're going to make it fancier, less simple. So here is kind of, I don't know. I like to pretend we have it first. Let's explore what it means to be a box. So like the constructor on a box, the default one, should just like set the value to 0, and like calling getVal should give it back, right? Get v.getVal, show me that value inside of you. It should be 0, and then if I were to set the value to 42, then if I print the value again, then it's 42. Something like that. So that's what it means to be a box. Very simple class. And so it has some methods, and it has one private member variable that it's holding on to that little value that's, we'll say, is an int. Okay? And so what can a box do? It has a constructor, getVal, and setVal. So it has a box. A method called box, right? Default constructor, it has a getter, getVal, which, what's that going to do? It's going to return our value, so it's an int return type, and it's just going to look at the value, not mess with it, so it's const. And then setVal, we got to give it the new value that we want to set into. It can't be const because of that. It's going to change the value member variable, and then it is going to be void because it just does the thing, right? It makes the effect happen. So those are the things we can implement. Well, let's get them there. And so this is boxes, box method. This is boxes, getVal method, boxes, setVal. Let's give them empty bodies and then fill them in. So the constructor of box, what should that do? It should set the val to 0. But we're cool kids, so we're going to do it with the initializer list. Val 0, just like that. We can have an empty body now. And then the getter for getVal, I'll just return that member variable called val. And finally, setVal, just like set my current value to whatever the new value that was passed to me was. Okay, so something like that. And then here I am using it in main. And this is just a very complicated program that prints 0 and 42. Does that make sense so far? It's a very simple class, holds on to a value. All right. And now I want to teach you the names of the big three. What are these things? So 3 new ideas today. So there's a thing called a destructor. There's a thing called a copy constructor. And then there's a thing called a copy assignment operator. All right. And I'm going to just give you the high-level overview of all of these right now, but I'm going to have plenty of slides on each of them in time. All right. So I want you to hear the words just once right now, even if they don't make enough sense. Okay. So the destructor is kind of the opposite of the constructor. It's the same name, like its name is the same name as your class, but with a tilde in front. This means the opposite, negation. It's going away. So this gets called for you when your object dies. It's kind of interesting to think about when its memory goes away. It gets called for you. You can't really call it, or you should never do it, even though you can. It's kind of the opposite of the constructor. So constructors happen, they get called when your object gets born, and then destructors happen when your object dies, in memory at least. And the copy constructor gets called when you're copying somebody else into you. So this is how you would use the copy constructor. It's another constructor. It's still the name of your class. It's a parameterized constructor, but the thing that it takes as a parameter is special. It takes another thing of your class. And the job of a copy constructor is, well, you have some other box, and you call it like this, where you're making a brand new box in the image of the old one. All right? It's like bring that other thing, copy it into me. That's what you want to do. Okay, so that's what a copy constructor's job is. It's just another constructor with a special parameter. It takes something else of your class's type so that it can bring it into the new thing you're making right now. Because again, constructors get called when things get built. That's a copy constructor. And then finally, copy assignment operator is very similar, but it's the equals sign. It's the assignment operator on boxes, on whatever your class is, and this is what it looks like. So it's like, let's say you have an original box, you have a second box that you have constructed in some other way, like it already exists. And then if you come along and you say, no, I would like B2 to like be a copy of B1 right now, that line, that hits the copy assignment operator, right? It's just an equal sign, but that's an operator we can mess with. So that's the thing, all right? Its job, of course, is to copy B1 into B2 in some way that makes sense for our class. So we should usually give an implementation of that, okay? So that's what that is. And yeah, again, it takes something else of your class's type, and it's always you, right? You at the deep down, if it's a method at least. So it takes somebody else and it brings other into you, and the return type looks a little weird. It's very similar to the output operator's return type. It returns essentially yourself again. We'll talk about how to do that, but it's going to return a reference to yourself after you finish that so that you can chain assignment operations. And I will show you that on a future slide, okay? So when you don't implement these, they still do exist. Like you can still say B2 equals B1, but you're hitting the default copy assignment operator, right? You're hitting the default copy constructor, the default destructor, and usually once you do fancy things in classes land, you're not going to get very good things out of the defaults anymore. So I'm going to show you that the default versions of these I'm going to show you what they would have been implemented as, all right? So they exist, like we don't get to see them, but by default we get them. So I'm going to show you what the defaults are explicitly. That's my goal right now, okay? I'm going to leave one important thing out, but we'll deal with that later. And I'll also print out whenever they get called so that you can see them all and how they work, okay? So I'm going to make a destructor, a copy constructor, and a copy assignment operator for our box class, and we're going to watch it work, okay? So let's see. How do I want to do this, and when do I want to change file names? That's the new question. Oh, we'll get there. We'll get there soon, all right? Yeah. So for now, yeah, we'll deal with that in just a second. So let's do the defaults. So here's what they are. Here's the new things. We've got a destructor, destructor, and that is tilde box. It's just the tilde with the name of your class. The copy constructor is going to look like this, right? This kind of pattern is going to be the name of your class. It's a constructor still, but the kind of thing it takes is usually it's a constant reference to some other thing of your type, but it doesn't have to be a constant reference. But usually you're just going to look at the old thing, look at the other thing, bring it into you. Okay, so that's a copy constructor. And then the copy assignment operator looks very similar, so I'm going to steal that copy assignment operator. And this one is it's called operator equals. It takes like yourself and somebody else still. It's going to return a box reference, and I think that's it. So those are the three things, the big three. Let's take them. Let me show you the defaults that you get when you implement them. Whee! And then I'll show you how they get called. So again, this is boxes tilde box method. Stuff like that. Oh wait, no, that's the return type. Excuse me. Box, colon. So let me show you all these bad boys, how they work. So when you don't give when you say nothing about these things, you're getting the default versions of the destructor, the copy assignment, the copy constructor. What do the defaults do? Here's what they do. The default destructor does nothing, which is usually not what you want a lot of the time. The default destructor is an empty body. It does nothing at all. But just for our purposes, I'm going to print something every time it gets called. So see out if the box destructor is getting called for a box with the val set to whatever val is. So that's, we're gonna see it work, but the default destructor does nothing at all, at least in this body. The default copy constructor's job is to copy construct all of your member variables from the other thing, which is sometimes what you want. So that's kind of nice. So the default copy constructor, which you get for free, what it does is it's going to copy in, let's see. It's going to copy in all of your member variables. It's going to set your member variables, like val is the only one here, from the other ones using kind of an initializer list. So val, make it from other.val. And that's pretty much the body of the copy constructor. Does that kind of make sense? The job of the default copy constructor is just like, all right, you are made up of your member variables. I'm going to copy into your member variables all of the other things, all of the other boxes stuff, because that's what it means, at least by default, to copy somebody else into you of your same type. So this is the box copy constructor, called for a box with val set to, let's do other.val. It's copying the other thing into us. They're about to be the same though. So that's the copy constructor. And then, any questions so far? It's like, I need to show you these, like how they get called still. But the copy assignment is also very similar. It's like somebody's calling the copy assignment operator. Box copy assignment. Called for box with val equal to, we'll do other.val again. And the job of the copy assignment operator is to copy assign all of your member variables. Copy assigns all the member variables. So it's going to do operator equals on, like, what are you? You're a box. You have all these member variables. I'm going to set your member variables equal to the other's member variables. And those are all calls to copy assignment, aren't they? Secretly. If they were like classes, you'd be hitting this for those things. So just for us, we have val equals other.val. So that's technically a call to operator equals, right? Secretly. Now we know. And the return type is a little weird for a copy assignment operator. What you have to do is you have to return a reference to ourselves. And that there's a weird way to do that. How do we get ourselves? Does anybody remember the secret way to, like, how do I get a hold on who I am right now inside of a class? How do I get my own object? What's that? Something, there's a similar idea, yeah, but it's not called me. If only it was called me, like me dot something. Yeah, I heard it. It's this. Remember that? This is the answer. That's the only way we know about ourselves. This, when you say the word this inside of a class implementation, it gives you a pointer to you. All right, that's what this does. This. So if I were to say this by itself, I'm going to get back a box star, which is almost what I want. It's a pointer to ourselves. If I just want myself, I can dereference that. So not return this, wrong type. It's return star this. That creates a box. It gives me. But every time if you return a reference, it's like it figures it out. It up converts it to a reference kind of, which is what we need here. So yeah, this like dereference it, turns it into a box, and then immediately creates a reference out of the deal. All right. So that's the secret. It's incomplete implementation here, but that's good enough for us now. So that's pretty much the defaults for all these things. Okay, and now let me show you how they get called. So the destructor is automatic. Like, it's going to get called for us whenever we lose a box. So I'll show that to you. I guess I can show that to you right now, because like this box B, it lives on the stack, right? It's part of main. Main is it's a local variable to main, so it lives on the stack frame for main. Once main returns, main stack stuff is not necessary anymore, and so right around here, right before the return, this B is going away. That's how it cleans up after itself. So there it is. It's calling it for us. The box destructor got called. All right. The default destructor is kind of useless. All it does is it default destructs all of your member variables, but we have one int, and so it's like there's no need. All right. There's nothing that we need to do ourselves. It's usually an empty body. Okay. So does it make sense how it's getting called though? It's like the B box is going away, and so it's being called for us, the destructor. So C++ kind of cleans up after things for us, usually. The other one, I guess I'll have to, let me split screen it so you can see at least these, if the types are important here. Let me show you how to call the copy constructor. So I have a box B now. Let's make a box B2 out of B. There I am calling the constructor that is a copy constructor, right? It's taken another box. So there it is. It's supposed to copy it into me, which makes sense, right? And then I can mess with B2, B2.setVal to 43. I don't know, make it different. See out B2.getVal. So it is another box at this point. So that for sure is calling the copy constructor, yeah. One interesting idea that calls it the copy constructor as well is if you were to say this line, box B3 equals B2. Surprisingly, this also calls the copy constructor rather than the copy assignment operator. And the reason for that is because you're creating box B3 on this line, right? So a constructor must be called. So it looks like a copy assignment, but really the box B3 doesn't exist yet. So really this is also secretly the same as this kind of line. It's building it and making it so that's a constructor call. It's a copy constructor call. This is still the copy constructor. Surprisingly. All right. And then I can mess with B3. Set it to 44, make it different. And then print B3's value so we see it all working. And so we're going to see a lot of copy constructor calls and also more destructor calls because I've made more things that go away at the end of main. Whee! There's an order to the madness as well. So here's the copy constructor call for the old box with 42. That was the original B. Then this one is still a copy constructor call, right? And it's B2 holds 43 now. And then the destructors for all these objects are being called in reverse order of their declaration. That's important. I will get to that later. But it goes with the most recent one first. That one dies first. Then B2, then B goes away. Okay? So and that's all happening at the end of main there because the memory is going to be reclaimed. Any questions about that so far? All right, let's do, finally, copy assignment. That's when you already have a box. It's already been constructed in some other way, like box B4. It's now been default constructed. Let's set its val to 45, something different. And now I can say B4 equals B3. It's like, I don't want it to be 45 anymore. I want it to be the same as whatever B3 held, which is 44. And then I can print B4's get val. It'll be also 44 at that point. Okay, so that's the job of the assignment operator. Copy somebody else's stuff into you. And there it is. We're hitting it right there. We're copying B3, which holds 44, into the current one. And so we see another 44 now, because like I changed it from 45 to 44 by using this kind of line. Okay? And that was this kind of implementation. Like you just gonna copy assign all of your member variables. That's the default that you get if you were to not implement this. All right? So everything I've just shown you, you got for free, except for the printing, of course. C++ does that for you automatically. You get those ideas of a copy constructor, a destructor, and a copy assignment operator. And sometimes, like, it does the right stuff, right? It makes sense. Like, this is the correct implementation for the copy assignment for a box. Like, copy in the val. Same for the copy constructor. Copy construct the val. Same for the destructor. There's nothing left to do. It's like, the int's going away, you're fine. All right? So sometimes the defaults are fun. And this is what the defaults are. Okay? Does that make enough sense so far? So these are just some things you gotta stare at for a while to fully understand, but those are the big three in a nutshell, okay? And then down here is where the destructors get called. So the destructors for all boxes get called right before they get reclaimed, we say. They get recycled. All their memory can be reused. But I guess the program's ending if this is main. If this was another function, though, could be reused. All right? So that is, I think, what I wanted to say. Did I mess that up at all? No, I think we're good. Yeah, so these are their declarations, and then these are their implementations. So we still good? Just something to stare at eventually. But if we are happy, I'd like to spice things up. So, okay. Let's mess with the box class now, all right? I would like to, instead of holding in val a single integer, I'd like to hold the value that the box is holding on to on the heap. I'd like to put it there instead. All right, so it's dynamic. It lives forever, potentially. I don't know. But this will eventually become important and relevant to the class. Like, this is kind of a silly thing to do to a box, I know. But if you're just holding one int. But I promise this is important. So, okay. If this is what we want to have happen, like in the constructor, how do we change things, right? Now in the constructor, we have to say, like, the type of val is now an int star, right? Because it's pointing somewhere to the heap. It's pointing to an address. It holds an address. And then we have to, like, make the thing on the heap, something like that. So that's important. We'll have to deal with that. And then get val and set val need to go into the thing on the heap. It's not just val anymore. It's like star val equals these things. And then, though, the implementations of the big three don't change. It's just like, all right, if you're copying val, just like set the val. The default implementations of the big three will not change. All right. And so let me copy all of this into, instead of box simple, I'll call it just box.cpp. All right. I think that's going to make the most sense to me. Let me tell you where I'm putting it. Boop. So that's the job of the box class now. Instead of putting this thing just as an int inside the box itself, it's going to be int star now. All right, it's going to hold an int on the heap. All right, and you could still do, so now in the constructor, let me do it in the body first. Now in the constructor, what must happen is, well, we need to make a value of 0, right, that the box holds on to. That's still the thing we want to have happen instead of this, right? We want to say, like, not val equals 0. That's the null pointer at that point. We want it to point to a new integer on the heap holding 0. Yeah? Question? I'm not sure what the question is. Just this one is just holding it as an int by itself versus it's holding a pointer to the heap. Does that make sense? Yeah. So yeah, there's no, this is a silly thing to do right now. I don't know if it's normal, but yeah, it's just, we want to hold instead of an int right here, an int star. Yeah. Other questions? Yeah, that's the whole point. It's going to hold it far away. It's going to hold a reference, like the address of some other int on the heap, somewhere far away. And so I want to make that int on the heap, new int, val equals new int. But now what's happened is it made the thing on the heap and it's holding garbage, right? So now val is pointing to somewhere on the heap, like address 100. It's holding that. But I want to set it to 0. All right, that's what I want to have happen. That's how the heap works. So val equals new int, and then star val, go to that thing on the heap, make it 0. Does that make sense to us why that's going to create this memory? Why it's going to look like that now? Because that's the start of it all. All right. There's faster ways to do this, by the way. You can do it in one fell swoop. You can say, instead of star val equals 0, you could have said a constructor call to the int operator, to the int, I don't know, type. You could have said new int 0, and what that would do is that would create a new int on the heap and also make it hold 0 all in one line. That's kind of cool. Well, it's really doing that two-step process anyway. So val now points to a new int on the heap that holds 0. You could have done this in the initializer list, but that would look a little weird, and there's too many new things at once. So we're going to do it like this. Okay. So that has created this memory in the constructor, and now if the int that I care about is on the heap and it's through val, star val, I need to put star val in my getters and setters. So like, what is the int that I want to get back? It's the thing that the heap is holding on to, star val. Same with set val. Go into the thing on the heap, star val, set it to be that new value that I want it to be now. Does that make sense? So that's what's going on there. Let's see. The implementations, the default implementations of the destructor, the, let's see, what is it? The copy constructor, the copy assignment operator, they are all, like, let's see, how do I want to, yeah. The copy assignment, they're all going to be the same. It's like, all right, you have a val, the other thing has a val too, just like bring that thing into you. Bring that other thing into you. Same implementations for the defaults of the copy constructor, the copy assignment operator, as well as the destructor. All right, just like it's all going away. We're fine. Okay, so that's what's happening. What else do I want to say? Let me try to make this work. All right, so I'm going to run it. I'm going to run this. There's no real difference. It's just like the ints are on the heap now. All right. And we're going to see some weird ideas. Just the second you do that, things will stop making sense. We'll call it box. So it's still the same program, mostly. It's like we've just changed the thing to be on the heap now. Like that, that, and that. All these are the same. We're still running these ideas right down here. Whee! And it looks like that. All right, I guess I could be starring things so that it says val equals something normal, but interestingly enough, it's printing val equals the same thing. We'll get to that, but it is printing 42, 43, and 44 a few times, so it's giving me the same output, which I guess is right, which makes sense. Let's see, what else do I want to say here? But some weird things are happening, all right? Let's see, how do I want to say this? Does anybody notice something that I haven't said yet? Because I'm going...
All the different numbers have the same address?
Yeah, all the same address. That seems wrong, maybe. Yeah, we'll get to that. Good. So let's see. Now let's talk about what's happening. So let's talk about destructors. So again, one got made for us automatically. The default destructor, what it does, you don't have to say it in the body. The default destructor is always empty, but what its job is to do before it even hits the body is to destruct all of your member variables. If they have their own destructors, go and call those as you are getting yourself destructed. So that makes a lot of sense, I hope. So it's implicitly calling the destructors of all the member variables. And even if you make your own, it's going to do that too. If they have some type that is a class, so you can actually overload that destructor. And the order of the destruction happens in reverse order of declaration, just like it was in main down here for the old ones, where you could see that happening. The old copy of those. It's going to happen in reverse order because maybe like the later ones build on top of the earlier ones. That's kind of what the thought process is there. So it's reverse order of declaration, and the default destructor always has an empty body because destructor calls are just implicit. It's always happening automatically for you. Okay, so let's see here. So the way that destruction happens is there's two main ways. Either you make a local variable within a function, and then you hit like a return or the closing curly brace. Right there, your function's done, right? All the local memory to it is going away, so it gets called for you. The other way to make a destructor call happen is to make a box on the heap, right? Because you could do that. New box on the heap, please. Then you use it. And once you're done with that thing on the heap, you say delete, right? That's what we say for things on the heap. We say delete v2. That's also going to call a destructor, which makes sense, right? This calls the destructor. Calls the destructor. So that's pretty cool. So yeah, they just get called for you right before things like go away in some way, either as a local variable or something on the heap that you've explicitly said, I'm done with this now. There is a problem with our default destructor right now. How do I want to show that to you? I'm sure it's probably fine. We'll deal with this later. There is a problem with our default destructor in that the second we say nothing, right? Nothing's happening in the default destructor, right? Nothing's happening. So when the box goes away, boop, it's gone, but the heap memory stays. Yeah? So we never talked about the heap memory in the destructor. It's a different place. It's an address. Val is holding on to the address, but it's just itself a number. It's going, all that memory is going away. But the thing on the heap, we never said delete for it, did we? So it stays. It itself stays. And so there is a memory leak every time we make a box now. And we hit this constructor call where it's a default constructed because it makes a new thing on the heap there. Okay, so that's what's going to happen, and I can prove that to you. Even though when your program ends, of course, all the memory associated with it goes away. But when you there's a way to ask C++, or there's a way to ask like Linux itself to go and check for memory leaks. There's a program called valgrind. It's really cool. It will run your program and check for memory leaks. So I'll say valgrind. Do I have that installed? Cool. Say -- leak check equals full, and then you try to run your program, /box. And what it does is it says, dun dun dun, leak summary, we definitely lost 8 bytes of memory. You leaked 8 bytes of memory, how dare you? All right, so that's what it's saying there, which is nice. There is an issue with our destructor. Do we see it now? Like, does that make sense? Like, when your boxes go away, now that you have something on the heap, like this part's what's getting gone. Anything on the heap that we make, separate place. Separate place, our job to mess with. Our job to reclaim when it's done. So that should be now the job of a destructor. Yeah? We've done some extra stuff. We need to clean up after ourselves. So that is our job of our destructor. Let's fix that. And then I'm going to get some errors for other reasons, and I'll have to deal with it. So default destructor is empty. We don't like that. We now, like, we're managing our own memory, so we're constructing memory, right? We got to destruct the memory too. So our job is to not be default anymore. We need to delete val off the heap, right? That's that thing. That thing is storing a memory address on the heap. We need to go there, delete it. That's something that does not get done for us. Delete val, right? Because like, what if you were using that by default? It's not getting deleted automatically. Because like, what if you're using that address for something else? You have full control over the heap, so you need to decide when that thing's going away. That's why it's not happening automatically. So that can fix it. Now it's no longer a leak. But I'm going to get some runtime errors. So to deal with that, how do I want to deal with that? Let me comment out a lot of stuff right now. So there are other issues. Whee! Dun, dun, dun. So let's just have this one. Still going to get destructed. But there won't be a runtime error now. Whee, cool, it worked. Destructor's getting called, and there's going to be no leaks. All heap blocks were freed. No leaks are possible. Thank you. Good job, us. So, nice. That's what we want to see, and I hope you see why. Like, we needed that. Any questions about the change to the destructor? We made memory. We must get rid of that memory ourselves. Okay? Let's see. What else do I want to say? Yeah. I guess, yeah, I'll have to deal with the issue that causes the runtime error right now, but we'll get there. So, okay, copy constructors now. Let's talk about this. So again, a copy constructor gets made for you automatically, and the default job of a copy constructor is to copy construct member variables. It's like, because that's what makes an object, right? Your object is made up of data. That data is member variables. It's like, I don't know, let's say you got an X and a Y or something in your objects, and you want to build B2 and B1's image. So the job of a copy constructor is like, you want to make a brand new thing called B2 using B1. It's going to bring in the X from B1 into the X of B2. It's going to bring in the Y of B1 into the Y of B2. And so it's going to make constructor calls, essentially. Like, no matter what those types were, it's going to construct them. Construct my new X from others' X. Construct my Y from others' Y. Okay? That's going to be how that works. And so that's what we did here. That one. Copy constructors being constructed, all of the member variables, right? That's the default. That's what you get, all right? And yeah, they get called in interesting places as well. So we know that this is a call to a copy constructor, right? That's a copy constructor call. We'll get back to that in a second. What else? That's a copy constructor call. There's also this line, right? Which doesn't look like a copy constructor call, but like, you're building the thing, it's getting made for you. One other way that a copy constructor gets called is when you have a function call or a method call that takes like a box, but it doesn't take a box reference. It doesn't take a box pointer. It takes just a box. And so it gets copied. I think you've probably heard that, right? Before, like how, like, call by address, call by reference, call by value. It's just copying something, and copying happens with a copy constructor if it's a class. It's an object. So yeah, when a class gets passed by value as an argument to a function or a method, a copy constructor is implicitly called because you're getting a copy. That argument, that parameter is getting that thing as a copy. All right, so that's kind of cool to think about. So for example, I'm going to make a silly function called val plus 1 It's going to add 1 to the value inside a box. And I'll show that to you. So let's see. Dun, dun, dun. How do I want to do this? So yeah, I want to make, here's the job. So I want to make a int val plus 1 on just a normal box. And its job is like to go into the box and return its value plus 1. Return b's get val plus 1. So it's a very simple function, okay? And if I call it right here, it's like cout val plus 1 on our box B. That should print 43, right? And when a parameter gets passed, right, when I'm calling val plus 1 with B, this B from main is being passed into this B in val plus 1. They're separate B's, right? Separate places in memory. It's a different stack frame. I'm getting a copy up here. It's a separate thing than this box B. Okay, remember all that? That's kind of why we use references most of the time. Like this probably should have been a const reference, right? Because we're just looking at a value. We don't want to copy things. But when you say it like this, when you say it like this, you are getting a copy. That's what it means. It's called by value. So B is passed as a copy using the copy constructor, because that's how things get copied in C++. So this argument, this parameter is being built right before the call from what was passed as a copy of the thing that was passed. That's the whole point. Now we know. So compile. Oops, not ready for that. There. Dun, dun, dun. Still, I have issues with the destructor. We will get there. Do I want to undo that? No, I'll just keep the error. That's fine. There's an error for a reason. We'll get there. But you see the copy constructor being called there. Interesting. So this call right there, it's jumping up. It's passing this box B into this box B. They're separate B's. Like this could have been called X. It's a separate place in memory. All right. So yeah, I think that's what I wanted to say. What else? I think that's the answer for now. Any questions about what a copy constructor does? It's just copying member variables by default. By default, that's what you get. Its job is to bring somebody else into the new thing that's being made right now. And it gets called in weird ways, weird places. So there's that one. We're so close. All right, we ready for copy assignment in more detail? All right. So again, you get a default copy assignment operator. Its job is to set every member variable using copy assignments, like the equal sign instead of the constructor call. So this is what copy assignment looks like. Where is it? It's like you've got the other thing that you're trying to copy into you has member variables. Bring all those into you using copy assignment calls for each of those things, whatever they are. And you return a reference to yourself. All right. So let's see here. Let's say you've got two boxes or two objects that have things like X and Y. Let's say there's two things inside of every object that we are looking at right now. X and Y, X's and Y's. So when let's say I've already got B1 and B2. They've already been constructed in some other way, but like I'm done with B2 right now with its current form. I'd like to bring B1 into B2. All right, so the job now is it's going to copy assign B1's X into B2's X. By default, this is what you get. And it's going to copy assign B1's Y into B2's Y, because that's what it means, right? So it's like my X equals other dot X. Now it's a assignment call, right? Copy assignment if they're class things, they're objects. Y equals other dot Y. And that's what we get, okay? And yeah, that's pretty much it. It's setting all of your member variables to the contents of the other member variables, all right? In the order that they're declared. So like if it was X then Y, you're doing it in that order by default. That's what you get. And then you return a reference to yourself, and now I get to tell you why. It's for, just like when you return a reference to the O stream and the output operator that lets you chain things, this lets you chain assignment operations, okay? So it lets you do this. Have you seen that you could do this before? So it's like, let's say you've got 3 int variables that are all unassigned to things, int x, y, z. And let's say that you want them all to be 42. You can do it all in one line, right? You can say x equals y equals z equals 42. Have you seen that before? That's a thing you can do. And this is why we return a reference to ourselves. Because like what happens when you run these calls, assuming they were like actual calls to a copy assignment, the way that the parentheses get drawn is like this for C++. That's its order of operations. And so what we want to have happen is like this one's going to get called first if only this results in the thing that was just like set. Like if this results in Z, which is what's going to happen, then this now turns into X equals Y equals Z. And then it does that. If we returned a reference to ourselves, that's what would be placed in the next version after this like gets evaluated a little bit. And then it's ready to set the Y. You see that? That's why we chain, or that's why we return a reference to ourselves, so you can chain those ideas. It lets you set a bunch of things all at once. Whee! And then, of course, this is going to turn into, right, the job is, like, this happens, it returns a reference to the thing that just got set itself, returns Y, and so this now turns into, after setting Y to Z, it turns into an assignment of X to be Y, and that's how they all get set in one line. I hope that makes a little bit of sense, but that's the idea. So the default, this is the copy assignment operator, which is the equal sign. Now we know, all right? So there's that. What else? So that's the default, and that's why we have to return a reference to ourselves. Does that make enough sense so far? And this is how we return a reference to ourselves. Return star this. This is technically not the full story for the default copy assignment operator. I just wasn't ready to show it to you yet. There's one last thing called a self-assignment check that you need to worry about. Do I want to deal with that right now? Potentially. Yeah. So here's something silly that you could do that would mess everything up right now. You can say box B1, and then you could say B1 equals B1. What should that do? Nothing, right? B1's already B1. It's having an identity crisis right now. It should stay B1, yeah? So this line should do nothing at all for us. Like that should just be absolutely, like nothing should happen when that gets run, okay? Like we shouldn't do any setting, like there's nothing to do at that point. That's just wasted work. So we should make this amount to nothing. I hope you see that. Make this do nothing to save us some time, right? Do nothing. It also avoids an issue potentially that we'll see later. So like it's a great idea to just like look for this, check for that happening, because maybe it happens in a weird way that we don't fully understand, like through pointers or something. We'll just make it not happen, all right? So we want to notice when we're trying to set ourselves into ourselves and just like return immediately, okay? So now the question is, how can we check if the other guy, how can we check if other is us? Do we have any ideas? Yeah, it would be this. Again, we could use addresses. And the other alternative answer that you might be thinking of is like, let's check if the vowels are equal. But that's not good enough, right? You could totally have two separate boxes holding on to 42, couldn't you? Doesn't mean they're the same box in memory. So memory, once you say the word memory, you should be thinking address. So the way that you can check if other is us, we can get the address of other by using the ampersand. And we can get our own address by saying this, couldn't we? So that's the secret, all right? That's how we can check. We say this. This. So let's add, it's called the self-assignment check. So wait, like we don't want this line to happen. It's useless to us. So let's add in the self-assignment check. So this is part of the default. I just needed to explain it. So this is really what you get. Self-assignment check. We don't let us copy ourselves into ourselves. That's a silly idea, all right? So if we in memory are the same place, right? Where we start in memory is the same place as where other starts in memory. We are the same box at that point. We have the same address. There's no other way. So we want to do absolutely nothing, and the way that we do absolutely nothing is return, but we still have something to return. It's always ourselves, a reference to ourselves. So we say return star this, all right? And that's the full default, okay? That's what happens. That's the self-assignment check, and so now I could add in those lines, and it wouldn't do anything, which is nice, all right? So I think that is the full story that I wanted to show you for the copy assignment operator. Are there any questions about that? That's the new full thing. So we know these guys now. We're more familiar with these things. Those are the big three, all right? And now I have a question for you, all right? So I want you to get with the people sitting next to you, say hello. I'm going to show this to you in a second, but knowing what we know now, we know what boxes are. I'll try to give you at least a little bit of this code. What do you want? I don't know. Let me show this to you maybe. This is a box. This is our class declaration. You may hopefully remember the implementation. So this is what a box looks like to us. This is what we can do. And here is my question to you. Draw a picture, take out paint, use the paper in front of you, and help each other. So I want you to discuss. Let's pretend with our current implementations of all the defaults, destructor, copy constructor, copy assignment operator, the value is on the heap right now. Say we run all of these lines. What is going to get printed with this cout line is my question to you. What should be printed? All right. So just like draw the pictures if you can, run the code in your mind. But there's going to be 3 numbers space separated that got printed at the end. What should happen? What do you guys think? All right. Please write it down. If you're brave, we can go to the written ice page. Please do attendance. Maybe I'll stop that after this is done. But if you'd like, as a group, to like elect a leader once you've come up with your final answer, like say what you think is going to be printed. All right. I'll give you a few minutes to try it out and discuss. And I'm here to help. If you have any questions about the implementations, I can remind you. What do you think is going to happen? I guess the destructor doesn't really matter here, but copy constructor breaks into another variable, copy operator also breaks into another variable at a different point in the life of the output. Oh wait. Just use the libraries once you learn all this stuff. Don't use the libraries. Those are very important. You should have those too. What should happen? What's gonna happen? It seems right after. Well, it kind of makes sense what should happen, right? Yeah, I'll give you another minute or so to discuss. Think about what's going to happen here. Upload your answer with the submit button if you'd like. How do I want to? I guess. And then I put that there. Apparently.
That's how.
Yeah. There we go. All right, that is enough time to reason in our minds, I hope. Let's see, it's like, all right, this first box is 42. This second box, we're creating it from B1, but then we're immediately setting its value to 43, right? Box B3 is being default constructed, value 0, but then it's bringing B2 into B3, so now it should hold whatever B2 has, so like the 43 is what it's holding, right? And then we set that to 44, right? So we think like 42, 43, 44, yeah, that would make sense to us, right? Nice. So that's what we're all agreeing on. I promise to stop that. Wouldn't it be nice, right? That would make so much sense. Like, all right, first it held 42. We messed with things. Then it's 43. Then it's 44. We can confirm that, right? Let's go to a new file. Let me copy in all this stuff. We're going to make some more changes later, though. Let's get rid of all of this and bring in the new code, and then I'll zoom back in again. Sometimes you can't copy and paste very easily from PowerPoint. We'll see if that happens right now. Oh, nice. I think it worked. So, all right, this is a new file. Box correct. I'm going to make some more changes. Error, but we see 44, 44, 44. None of us were expecting that, were we? This is why we're learning about this. So this is, the answer is not 42, 43, 44. Like, yes. Yes. That's exactly the problem right now. Let me show that to you. All right? So this is surprising. This is the defaults doing the wrong thing now, because we want differences. All right, so here's what's happening. All right, when we run these lines, let me draw very specifically what's going on. So box B1, what happens when you run a default constructor? It's making a box on the heap, right? It's making that new int. It's what we said happens in the constructor. We're making a brand new int on the heap. That's what val is pointing to. So val is holding the address of this brand new thing on the heap, which I've set to 0. So I mean, that's 100. Address 100. Go right there, please. I don't know. Let's put this in a more central location for reasons. Put that there. Whee! Okay. Then watch what happens. Build box B2 by copying B1's member variables in B1's image. The default, right? What the default does is it says, make the val others val. Yes? That's what happens. Make the val others val means make this val equal to this val. Their addresses now, though. That's what just happened. You see it? Oh, sorry, we're supposed to make it 42 first. This line, make it 42. Now it's 42. Cool, 42. And then now we run this line, copy my val, my new val becomes the old val. They're both 100. See that? So they're both pointing right here. And now when I say B2 set val, 43, that's 43. If I ask for B1's val right now, what would it get?
43.
It would give me 43 because that's the one place it's pointing to now. That's where val is pointing to. It would return star val. Those are the same place in memory now. Did we want that? Probably not. So, okay. Box B3, this one's default constructor. So again, we're making a new int in memory. Having val hold that right now, like 104. That's the address. It's pointing there. It's holding 0. But then we come along and we say B3 equals B2, and we run the copy assignment now. So it's not the self-assignment check. Like the self-assignment check fails. These are two separate places in memory. That's fine. Two separate boxes. So we'll run the rest. We'll say my val equals others val. So B3's val equals B2's val. So it's not pointing to 100 anymore. Or it's not pointing to 104 more. It's pointing to 100. So we've chopped that off. And now it's pointing here. And then we say set val at 44. Boop. So now it's pointing there. Star is the val, which gets me to here now. Sets it to 44. Do you see that? And so now, no matter what, we're getting 44, 44, 44. They're all looking at that same box. And also, this copy assignment leaked memory, didn't it?
Yeah.
So we just lost the old thing. Just reset. I don't have that address anymore. I don't know where it is. So, maybe the defaults aren't right all the time. Maybe we should learn about this. So, okay, what we wanted to have happen, of course, was B1 constructs itself, makes a value on the heap, right? Initially set to 0. Where do I want to put this? Let's put it down here. Initially set to 0. And then we come along and, of course, set that to 42. What would we have liked to have happen for the copy constructor was, all right, make B2 have a val on the heap that's separate, so I can set it separately, but put the value in that box. Put the value in that box the same as this one, right? That's what I really wanted this whole time. Make it 42. Separate place, though, that I can mess with in a different way and not have it be attached. Then make it 43. Okay, and then box B3, make your brand new thing on the heap that holds 0, because it's a default constructor call right there. And then B3 equals B2. What should happen there? Let me draw it in green what should happen for the copy assignment, because it's a little more complicated. So when you have copy assignment, you already have existing stuff. You better clean up that stuff if you're trying to get somebody else into you, all right? Alternatively, you can go here and like reset it, but just like, let's talk about a generic idea right now. A better idea that will work across different implementations of different ideas of classes and things is, all right, you see a copy assignment, you yourself are done. You're bringing somebody else into you, so let's essentially get rid of ourselves. Delete that thing off the heap. We're not using it anymore. Then pretty much do the copy constructor's job again, because then you can copy and paste. It's like, all right, make a new value on the heap that holds a copy of B2's values thing, like the 43, put that there, and then have it point to that. Chop this off, and that's fine to be chopped off now, because like we deleted it. Arrows are all over the place. And then we want to set the val of that to 44. Now these really are. So let's set val 44, so it's going to, sorry, I was in green mode, wasn't I? So now it's going to follow that pointer, get to the val, set it to 44. And we have 3 separate places on the heap now that each hold their own values and can be set independently of one another. That's probably what we really wanted. Yes? Are there any questions about the difference? Because the implementation, like, we'll see. We'll see. Just we have to use new some more, kind of. But that's what we would like to have happen. Okay? And so there's a word for this way of doing things, and a word for this way of doing things. And the word is shallow copy. The phrases are shallow copy and deep copy. All right? What the defaults gave us is called a shallow copy. We're copying addresses. And so deep down, we were pointing to the same place in memory. And so if we touched that memory through one of those addresses, through a val, it would have given us the same place as touching it through the other address. All right? So they're both copying, right? They're both copying like X into Y, but the way that they do it is completely different. That's called a shallow copy, where you're just copying addresses. You're getting deep down at the same place in memory. Like this is the same address. This is like address 100. That's what X is pointing to. That's what Y is also pointing to. A deep copy looks like this. It's like, all right, I want to copy X into Y. So what I'll do is I'll take what X is really holding, what it's really pointing to, and I'll recreate that image, recreate that picture down here, shiny and new if it's on the heap or something. Like I'll make a brand new copy of all that stuff that X was holding on to just for Y to have. You see the difference there? So now, like, they're separate places, and if I mess with X's stuff, I'm not messing with Y's stuff. Whereas if I was here in the shallow copy land, I was doing the same thing, messing with the same stuff. Okay? So yeah, that's what was going on, and like the default copy constructor, copy assignment operator, they were doing shallow copies. All right? They're doing a shallow copy, and that's also why I was getting some errors at the end, because it was trying to destruct and delete this memory 3 separate times, wasn't it? You can only do that once. It complains the second time. So that's what was going on there. And yeah, if the idea is, like, usually this is involving pointers, like we don't want the shallow copy a lot of the time, like especially if there's pointers. We're just copying the pointers values, which are addresses, so they're going to point to the same single location at that point. So that's not the idea, right? We want to copy instead like what they're pointing to. So go further, go deep down, copy the entire picture of memory. Okay, that's what a deep copy does. Copy every single piece of data as far down, follow all the pointers you need to, all right? And we'll deal with it. So in this new file that I've made for us called box_correct, we'll have the final version of what everything should be. Okay, let's fix it all now. Let's see here. I think that's what I wanted to say. Okay, shallow copy versus deep copy. So we're already in that file. Let's fix them all. So the destructor is still fine. The destructor is doing the right job, even though it's causing an error at the end. It's because of the other things. The destructor's job is to delete our value. Like that was on the heap, get rid of it. Cool. These guys now, let's fix it a little bit more. So let's see, where was I? I want to be here. Instead of doing it this way, I'll go back to the body. Though you could have done it in the copy assignment, or sorry, you could have done it in the initializer list for the copy constructor. But all right, the job of the copy constructor now is to do a deep copy of things, to make this happen. It's like when I bring in B2, make a brand new box on the heap. So I need to be saying new. I need to say the word new in the copy constructor. So val equals new int. Make a brand new int on the heap. Holding, what that holds though is a copy of the other's value. Yes? So in one line I can do it this way, put whatever I want here. What is the value I want to hold on the heap? It is a copy of other's value. But other.val is just a pointer. Follow that, give me the number it's really pointing to. So new, we're making a brand new box of memory, not a box itself. Brand new box of memory on the heap. So new, let's say new int on the heap for this val. And that's what we really wanted, a separate place. Okay? It's holding a copy of the value that other is pointing to. All right? So now we're getting the 42 again or something, whatever it was. So that's that correct answer. Now for copy assignment, it's the same deal, more or less, though we also have some extra stuff to do. So for copy assignment, you had an old thing. You had this guy. You're now replacing it. It's like you're saying I'm done with the old stuff by setting somebody else into you. So a good pattern, so you can kind of copy a lot of what you're doing in the copy constructor, is just like delete the old stuff, clean up whatever you have right now, and bring everything brand new in to you. All right. So the very first step should be before you copy assign all the member variables, delete my current value off the heap. I'm not using it anymore. I'm going to copy in other stuff into a brand new place on the heap. You could have like optimized this by like messing with your own stuff that's already on the heap, but let's do it this way. It's simpler to think about because it's more or less the copy constructor at that point. So now I can just do this again, right? It's like now I'm not leaking memory. I want to make a brand new int on the heap for my val now. Okay, that's what I'd like to do. That's perfect. Okay, so now I'm bringing in a new value on the heap, making a brand new box, holding a copy of the integer that the other thing was pointing to. All right, that's what I wanted. This whole time, after the self-assignment check, return star this, we should be good. Okay, so that's the correct version of the copy assignment operator. What else do I want to say? I think that's more or less it. Let me just double check, make sure it's all there. Yeah, let's run it now. See if we get 42, 43, 44, and no errors, and no memory leaks. Look at us. There's my 42, 43, 44. So that confirms, right? They're all different places. And also this output confirms they're different places. The value for the first box was that address. Value for the second box was that address. Value for the third box was that address. Separate places on the heap. Beautiful. Individually able to be messed with. And then also, did we leak memory is now the question. So that's val grind, leak check full, run your program. All heap blocks were freed. No leaks are possible. Lovely. So yeah, that's the full story. All right. I think that's what I wanted to say. Yeah. Any questions about that? Do we see the beauty of it all now? We have this power now. We can make it our own. All right. if we are good with that, just like a recap of what we've just talked about is this is why we learn about the big three. So the default implementations, all these guys, they work a lot of the time, but sometimes they don't. All right. The way that they start breaking down usually is when you deal with the heap, right? Because you start managing your own memory, it can't do it for you at that point, right? Especially when the heap is involved. If you don't use the heap, like in our original implementation of the box, like everything was fine, it was working. But the second you try to manage your own memory, it's not going to work right usually. All involved. So there. Okay. So if you don't like the defaults, if they're not working for you, you must override them. You must give them actual concrete implementations. And in this class, these defaults are not going to work a lot of the time. So your next lab, after the current one on vectors, try to think about your vectors lab right now. It's leaking memory. It's messing with stuff. It's not working right. These defaults are not working correctly for our vectors because things are happening on the heap. So that's why there's a part 2 to that lab, okay? That's where we're going. So yeah, I think that's what I wanted to say about all that. And I guess one last idea. I want you to think about this. Go back to the written nice page as a group. I'll clear it out one last time. If you're already on the page, refresh it so it goes back to a blank slate. But here's my question for you. One last question for the day. Here's the implementation, the relevant implementation of the copy assignment operator. Something like that. Here's the copy assignment operator. And here's like the correct new implementation of all the stuff that we've done. It's like we need all this. Here it all is. Try to tell me, like, if this is what memory looks like, I've got B3 and I've got, like, it's pointing to a value on the heap that looks like this. If I were to get rid of this self-assignment check and I were to run this line B3 equals B3, what would happen? Try to imagine, like, if I got rid of that check and I just ran all those lines, if we didn't use that self-assignment check in the copy assignment operator, if I ran B3 equals B3, what would this picture look like? Try to describe it in words. Would things go wrong? Would it still work out? Like, there's a reason we have this, and I want you to try to see it and explain it in as much detail as possible. All right, and then I'll draw a picture after you think about it. So give that a try. Run these lines on paper if you can, or in paint. It's good practice. There's a reason we have that check, especially once we start overriding the defaults. You see it. You see what's going to happen.
Because if you don't, because for every new, there needs one delete, and if there's no delete, there's something in memory, right? Or yeah, there'll be a memory.
Another minute or so to discuss. Get your ideas in there. It's okay if you don't fully see it. I'll draw the picture. It's good practice thinking about it.
delete the value. Basically, like the value add. That it's going to say that where it's value garbage. That actually deletes 42 on Q.
Yeah.
The values
Let us see what we think. Was there time to type it? I don't know. So it delete itself. Good. Nice, nice, nice. We have some ideas. Anybody in words want to explain what their thoughts were? Maybe we didn't have enough time to write it all down, which is fine. Weird things are going to happen, right? It's the moral of that story. So there's a reason we have it. Let me try to draw the picture for you. So here. If we didn't have that check, which would give up before doing the rest of those lines, if we just let it fall through and run those lines, what would happen? So the first thing you would say is delete val. Goodbye. And then, so we just lost the 42, didn't we? We just lost the 42. We should no longer go through this pointer because it's pointing to who knows what at this point. It's undefined behavior. It could be a random value. It could still be 42 maybe, but like we have no control over what's happening, right? And then the next thing we say is, all right, val equals a new int on the heap holding a copy of other's val, but it's going to get there, right? Because other is us. It's going to follow val and try to read from here. See that? Uh-oh. It's like it's going to put who knows what right here. 42, maybe. I don't know. 42, question mark. We have no control over what's happening. Then it's going to chop it off, right? And then val equals that thing. Like, goodbye, here, have this. That is a huge issue, right? We're trying to read through a deleted address. See that happening? So it won't, like, if you just let it fall through, sometimes, a lot of the time, when you override things and you have a more complicated than default implementation, now suddenly you've introduced errors, right? You shouldn't let it fall through. Even though you think like it does nothing, it won't just do nothing. You might delete yourself, which is a little disgusting, pieces of yourself. And then you try to read those pieces and then who knows what you're going to get, okay? So we have no control over what we see. Sometimes it might be 42. And it will work sometimes, but then like when things are really important and it's crunch time, then suddenly it'll stop working because like you can't bank on that. So fun. All right, that's the secret. That's what I wanted to say. So now we know why we have it, right? If we didn't have that check to do nothing, right, then it's going to delete all of our heap memory because that's the job of a copy assignment operator, and it recreates a deep copy of the other thing, but the other thing is us, so it's going to try to make a deep copy of ourselves by following all the pointers that we just deleted off the heap. So that's no fun. It just tries to do that. Sometimes it'll be 42, but you cannot control whether or not it is. It's just like it's implementation dependent. Because like when you run delete, it's C++ code running at that point, and it depends on which compiler you use to compile, which operating system you're running on, like how many things were already on the heap, like is it going to clean a bunch of stuff up at once, right? Who knows? All right, you have no control. So you're trying to deep copy yourself through deleted memory. So that is called undefined behavior. If you've never heard that word, it's just like that a bunch of people have gotten into a room and they're like, we're going to list exactly how C++ should run so that if anybody wants to make a compiler, they just follow the list and then they do these things. But some things they leave up to the implementers. And those things are called undefined behavior things. So this is one of them. Like what happens when you go through a deleted address? Implementation dependence, undefined behavior, anything goes at that point. It could like wipe your bank accounts. Technically, that would be according to the standard. All right. So always we want that self-assignment check. All right. And that's why we have it. So I hope that makes sense. Any questions about that? See the beauty of it all, hopefully. And of course, I'm going to give you all this code right now after the class is over. So definitely take a look at it. It's an important topic. It is a difficult topic. All right. So let me just lightning round give you a way to like understand how all these are happening. All right, so default constructor looks like this. You say the name, say semicolon, don't give any parameters. That's a default constructor call. You could also be calling the constructor as you make something on the heap box star B equals, make a new box on the heap. Make the box itself also on the heap. That's okay. You might want to do that one day. But again, if you put a semicolon right there, that's calling the default constructor. You could call a parameterized constructor by putting arguments right there. All right. And so there's a parameterized constructor. Box B, maybe it took an int. Could take anything. It's up to you. You could have done that on the heap as well. Like make a new box on the heap and call that parameterized constructor with 42. That's where you'd put it. If you made it on the heap, it's like after the name of the type at that point. All right. And then we got the copy constructor. That's a new thing today. It's copying the B into the B2 in this example. All right. And again, let's say that everything was on the heap. So both B and B2 are on the heap. I want to make B2 in the image of B. I want to say new box. But the copy, you can't just say if B is also on the heap, you can't just say B there because that's not the right type anymore. The type of a copy constructor is supposed to take a box as well. So it's got to be star B. Star B to actually get to that box if it was also on the heap. Okay, so that would be calling the copy constructor. That's what it would look like if you were to build a thing on the heap. That's where you'd put the arguments. And then copy assignment is trying to copy, like you've already constructed your object, but you're done with whatever it holds right now. Like I'm tired of whatever it held. I would like to copy whatever B's stuff is. B's stuff, put that into B2 now. That's what we're doing, okay? And so I guess the way to do that, if these things were on the heap, they would be pointers to boxes. You'd say something like this, right? Star B2 equals star B. That's what it would look like in that context. Boop, something like that. So that's copy assignment, but on the stack, on the heap. One way or another, you just got to get to the boxes. And then finally, the destructor is implicit. So like either you made a local thing, it will implicitly have the destructor called on it, like at the end of that scope, like when you see a return or when you see a closing curly brace, then it goes away right there. Or if it were on the heap, it's your job, right? If you had a box on the heap, you say delete, give the address of that box, delete B3, if that held the address. That would go, reclaim the memory, after first calling the destructor to clean up. Let me spell that better. Delete B3. Okay? So that, I guess that's kind of the full story. That's how you make all these things happen. All right, and now we know how to implement them too. Okay? Any questions about that or the syntax, anything like that? Because I think that's enough. That's enough for today. We'll come back next time and continue. There's more to talk about. We want to get to the big three for vectors, of course. But that's the start of it all. All right. And it is a little bit of a complicated topic, but I think you're seeing a little bit of it now too. All right. So yeah, I think that's all that I wanted to say for the day. Yeah, I'll give you a new lab, but that'll be a problem for Thursday. Okay. Any last questions before I stop the recording? All right.